Now we are going to quickly revise what is the expression for work done. Now, all of us know that the work done by any force is given by force into the displacement. But this time we are going to write it in the vector form. What if the force and the displacement are not in the same direction? An example is shown here. Now, if this man is pushing this object, he's applying force in this direction. Whereas if you look at the displacement of this object happens in this direction. Here is the displacement vector shown to us, this D. And this is the force, F vector. So let's write these things in their vector notation form. So this D, I'll write as D vector. This F as F vector. We can resolve this vector into two components. One, the horizontal component, F cos theta, and the vertical component, F sine theta. Now, the F sine theta component, the vertical component, is not responsible for any displacement at all. This object is not moving up and down. So no displacement in the vertical direction, and that's why the impact that this force makes is nil. All the impact is because of the horizontal component of force, and hence the work is given in this format. Now, if I want to represent the expression for work done in terms of vectors, how do I do that? See, we all know work done is a scalar quantity. How do we get a scalar quantity from two vector quantities? One of the ways is the scalar product or the dot product. F dot S, surprisingly, F dot S is defined as magnitude of force multiplied by magnitude of distance multiplied by cosine of the angle between them. The angle between them is theta in this case. So work done is given in this format. This format is interesting and it helps us in a lot of cases when the force given to us is in the vector notation, something like if the force is given to us as, the force vector is given to as Fx I cap plus Fy j cap plus Fz k cap. So in terms of orthogonal unit vectors, I've represented some force. If force is like this, and the displacement is also given something like this, the displacement vector is given displacement in the x direction, I cap, plus displacement in the y direction, j cap, plus displacement in the z direction, k cap. How do we find the work done then? Now it's easy. We know if vectors are represented like that, we know how to find their dot product, and hence we can find the work done quickly. So that's why this format is important to remember. Let's apply this quickly to a problem. So here's a question, a very simple one. This came just this year, in the year 2025, in the JEE mains paper. It says the force, again, given in the format that we just discussed, given in terms of orthogonal unit vectors, a force this much is applied on a particle and it undergoes a displacement this much. Well, force and displacements, the vectors are given to us. What will be the value of B? Here is B. The y component of force, that's B. What would be its value if work done on the particle is 0? So we know that work done is 0, and that will help us find out the value of B. We know that work done is given by F dot S, the dot product of the two vectors. And the work done is 0. So we'll put 0 here. Force, we'll write the expression for force, which is this, we dot product this with the displacement vector, I minus 2j, I cap minus 2j cap minus k cap. So 2i into I, this will be retained. I dot j, I dot k will all cancel out because dot product of two perpendicular vectors is going to be 0, because cos theta between I vector and j vector is 90. The theta between I and j vector is 90, so cos theta is 0. And that's why only these will be retained. So 2i into I, that's 2. Similarly, b into j multiplied by minus 2 into j, that's going to be minus 2b plus k minus k, so that's going to be minus 1. If this is 0, can you find out the value of b? It's very simple to find now. It's 1 minus 2, that is minus 1 by minus 2, that is the value of b, half. So what would be the answer then? Option number